Friends, good morning to everyone. In the last presentation, we were dealing with the application of continuous flow reactors. We know that enormous opportunities are there for further research in this continuous flow reaction because of the fact that it can handle hazardous substances in a very efficient and effective manner, as it has very high heat and mass transfer ratio. You have seen the examples of synthesis of diphenhydramine and also the synthesis of rufinamide. In continuation of that, let us look into the other few applications of synthesis of APIs by using this continuous flow method. Today, let us discuss the synthesis of ibuprofen by continuous flow system. Here, ibuprofen is one of the NSAIDs which has been in high demand for its utility. It is one of the APIs whose requirement is more than 100 tons per annum worldwide. Here is the synthetic method using continuous flow system given and explained. The isobutyl benzene was treated with propionyl chloride in the presence of Lewis acid catalyst. All these three were mixed without any solvent and then fed into the perfluoroalkoxy reactor coil of 250 microliter capacity and heated at 87 degrees centigrade for a minute time. The reaction, Friedel-Crafts acylation, occurred within 60 seconds, which was neutralized with HCl, and the crude precipitated was separated by using an inline membrane separator at 200 psig pressure, where the HCl, aluminum and water has been separated, and the acylated product 70, what we have seen here, has been achieved in 95% yield. The acylated product was mixed with triethyl orthoformate in dimethyl formamide solution, which was subjected to 1,2 aryl oxidative migration using iodine monochloride as promoter in a 900 microliter PFA reactor coil. The reaction time is just 60 seconds. The 1,2 aryl migration occurred to give the ester form of ibuprofen. In 91% yield, the crude product in the form of ester was combined with methanol water mixture containing sodium hydroxide and 2 mercaptoethanol, which was heated at 90 degrees centigrade in a PFA reactor coil for 1 minute. Saponification occurred to give rise to the sodium salt of ibuprofen, which was separated at 200 psig, and the yield was 83%. This has been achieved with an output of 8.1 gram per hour. This is the salient features of this ibuprofen synthesis. We use PFA reactor. It's a Teflon reactor which is highly resistant to chemicals and highly resistant to thermal energy, and the reaction and the volume of it is only 900 microliters or 470 microliters and so on and so forth. Here saponification has been carried out in a 3.9 ml PFA reactor coil, and the whole reaction occurs in 3 minutes. Within 3 minutes the total reaction occurs, and acylation can be carried out very easily in a neat manner without any solvent. 1,2 aryl oxidative migration occurs, and at ambient reaction conditions. Similarly, another drug molecule, telmisartan, which comes under the category of angiotensin receptor antagonist, which finds its use in the treatment of hypertension, has been synthesized by continuous flow system. The 2-propyl 4-methyl derivative of imidazole was dissolved in N-methylpyrrolidine and alkylated using bromomethyl biphenyl derivative. This is a convergent strategy which do not require the purification of the intermediates, and there is no need of the solvent exchange. The whole reaction is carried out by using N-methylpyrrolidone. To be precise, the N-alkylation of the imidazole has been carried out in the presence of tertiary butoxide in a 10 ml reactor coil by heating at 100 degrees centigrade for 20 minutes. The residence time is here 20 minutes. The N-alkylation occurs. The N-methylpyrrolidone has been used as a solvent of choice as it is a polar aprotic solvent which is miscible with water, and hence it do not precipitate. And then the precipitation occur, the possibility of clogging also is possible, and that can be prevented by using this reagent, this solvent. The formed alkylated derivative was hydrolyzed by using potassium hydroxide solution in a 10 ml reactor coil by heating at 120 degrees centigrade for 10 minutes. The ester hydrolysis occurs to give rise to corresponding carboxylic acid derivative. Further, the compound obtained, the hydrolyzed derivative, was mixed with 2-bromo 1-methyl imidazole dissolved in N-methylpyrrolidone water mixture, and it is fed into the reactor in which it is packed with palladium catalyst. And this reactor, which is packed with palladium catalyst, is heated at 180 degrees centigrade, and the residence time was 5 minutes, and the Suzuki coupling occurred to give rise to telmisartan in quantitative yields, that is 81% yield was achieved after the acid-base workup. Here we can see the example of the type 4 reaction where the catalyst is packed in the reactor and the reactants moves through this, and through the in the process when it moves, at the end we collect the Suzuki coupled product. Here the catalyst bed reactor and the normal tube reactor are combined together to achieve the synthesis of telmisartan in quantitative yields. This is another example where the API has been synthesized by utilizing continuous flow system. The continuous flow system has also been utilized for the synthesis of the enantiomerically pure compound by stereoselective synthesis. That will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.